Good evening, dear dreamer, and welcome back to Boring Science for Sleep. I'm so glad you've joined me here again, in this quiet corner of the night where science becomes a lullaby and the universe itself keeps us company as we drift into rest. Wherever you are listening from, whether it's the soft hush of midnight or the gentle quiet before dawn, this is your time to slow down. Let your breath deepen, let your body soften, and let your thoughts wander lightly like tiny fragments of stardust carried on cosmic winds. Not so long ago, astronomers spotted something unusual in our skies. In 2017, it was ʻOumuamua, a shard of stone from another star system, strange, fleeting, and gone before we could truly understand it. Many thought we might never see such a visitor again. And yet, just 2 years later, in 2019, another traveler arrived. This one was different. It was not shy or silent, but radiant, draped in a glowing veil, trailing a long silver tail. Its name was Gennady Borisov. Borisov was the second interstellar object ever discovered. Unlike ʻOumuamua, it looked familiar, like the comets we already knew, a ball of ice and dust, shedding vapor as it neared the sun, stretching a luminous tail across the stars. And yet, it was not ours. It was a wanderer from another sun, another system, carrying secrets from a world we may never see. So tonight, let's follow its story together, how it was discovered by an amateur astronomer with a homemade telescope, what its shimmering tail revealed, and the gentle truth it brought with it, that the galaxy is alive with travelers, and even across vast distances, we are not as alone as we might sometimes feel. So, settle in. Find your most comfortable position, let your eyes grow heavy, and let curiosity carry you gently outward, following this comet's quiet path through the stars. Close your eyes for a moment, dear dreamer, and picture the scene. It is the summer of 2019, far from the gleaming domes of the world's great observatories. Not in Hawaii, not in Chile, not in California, but in Crimea, on the Black Sea, where the land stretches into the water like a quiet peninsula. There, beneath the same stars we all share, an astronomer is at work, not a professional with a team of graduate students, but a man working largely alone. His name is Gennady Borisov. Borisov was not part of the large international collaborations that map the sky with machines the size of buildings. He was what we call an amateur astronomer, though the word amateur in this context means something richer than hobbyist. It comes from the Latin amator, a lover. An amateur is one who does something for love. And Borisov loved the stars deeply enough to dedicate his life, his hands, his evenings, and his patience to them. In a small workshop, he built telescopes of his own design. He ground mirrors, assembled tubes, adjusted lenses, until they were sharp enough to pierce the heavens. This, too, is an act of devotion, because to shape glass that can focus starlight is not easy. It requires long hours bent over tools, the steady rhythm of grinding, the careful listening of fingertips against glass. Each imperfection, each scratch, could scatter light. But through persistence, through care, Borisov crafted instruments that became extensions of his gaze. On the morning of the 30th of August, 2019, he pointed one of those telescopes toward the sky and noticed something unusual. A faint smudge, a tiny blur against the black, moving differently from the background stars. He watched, measured, checked again. The blur was no error. It was real. Something new had entered the field of vision. At first glance, it looked like a comet, an icy body shedding vapor, surrounded by a faint haze, a coma glowing softly. This was nothing unusual. Amateur astronomers have discovered comets before. But as days passed, and more observatories turned their instruments toward it, the calculations began to paint a startling picture. This comet's path was hyperbolic, not elliptical like the planets, not closed like the comets that loop in and out of our sun's grasp, but open. Its trajectory was not bound. It was not circling back. It was passing through once, from far away, and would never return. The numbers confirmed what had seemed almost impossible. This comet had come from another star system. The discovery was soon confirmed by the International Astronomical Union. The object was designated Gennady Borisov, the second known interstellar object, after ʻOumuamua the first, and the first confirmed interstellar comet. The 2I stood for Second Interstellar, and Borisov honored the man whose patient eyes and handmade telescope had caught it first. Imagine the feeling. To look through glass polished by your own hands and see something that no human has ever seen before. A comet born under another sun, wandering for eons through the cold dark now brushing past our own system. To catch such a visitor not with billion-dollar machines, but with devotion, persistence, and love. It was poetic that the discoverer was not part of an elite team, but a single person guided by curiosity. In that moment, Borisov joined the ranks of history's great sky watchers, ordinary people whose patient eyes revealed extraordinary truths. Just as shepherds once traced constellations, just as sailors once followed stars across oceans, he had added his own discovery to humanity's celestial map. And what a discovery it was. Unlike ʻOumuamua, which had left us puzzled with its strange shape and behavior, Borisov looked reassuringly familiar. Its coma shone brightly, its tail stretched long, its chemistry betrayed the fingerprints of ice and dust. It was, unmistakably, a comet, yet one from beyond. A paradox, familiar and yet utterly foreign. For astronomers, this was a gift. ʻOumuamua had been too strange and too brief, gone before telescopes could study it deeply. But Borisov lingered, visible for months, giving scientists a chance to aim instruments at it, to analyze its spectrum, to see what a comet from another system was truly made of. And so, a comet that might have passed unnoticed became one of the most important astronomical events of the decade. Not discovered by a great survey telescope, but by the careful watching of a man whose love for the stars gave him patience enough to notice a faint smudge of light. Let us pause here and reflect on the quiet lesson. Great discoveries are not always made in grand halls. Sometimes they are made in backyards, on hillsides, in small observatories built by hand. They are made by those who simply love the night sky enough to look up, night after night, to listen for whispers others might miss. You can imagine Borisov himself stepping away from the eyepiece, heart racing, then slowing as the realization settled. He had seen something that had crossed gulfs of space for millions of years before appearing in his lens. A message, not in words, but in presence. And we too can carry that message as we rest, that even in our smallness, even in our solitude, we are connected. The universe delivers its wonders not only to the powerful, but to the patient, to those willing to look up. So as you settle more deeply into stillness, imagine standing with Borisov on that quiet morning. The telescope hums faintly, the sky above is alive with stars, and among them, one faint smudge glows, a comet from another star. No fanfare, no noise, just a quiet discovery, enough to change how we see ourselves in the cosmos. And yet, what made Borisov so remarkable was not only its origin, but its nature. For unlike the mysterious shard ʻOumuamua, this visitor looked familiar. It wore the shimmering veil of a comet, glowing with a coma and trailing a long tail. In the next part of our journey, we'll explore this paradox, how Borisov was both a stranger and yet comfortingly like the comets we already knew. When ʻOumuamua appeared in 2017, it left behind a trail of questions rather than answers. Its odd shape, its strange acceleration, its silence, it did not resemble any comet or asteroid we had known. It came, and before we could fully understand it, it was gone. 2 years later, when 2I, Borisov entered our skies, astronomers braced for another enigma, but what they saw was, in its essence, something deeply familiar. Borisov looked like a comet. From the first observations, its coma, that glowing veil of gas surrounding the nucleus, shone clearly. The coma is the hallmark of a comet, sunlight warming its icy heart, turning solid frost into vapor, which spreads outward in a misty halo. Against the blackness of space, Borisov's coma shimmered like a soft lantern. And then, of course, there was the tail. A comet's tail is not a single thing, but usually two, one made of gas, streaming straight away from the sun, and another of dust, curving along its orbital path. Borisov displayed both. Its dust tail was long and faintly curved, its gas tail thin and straight like a silver spear across the stars. For astronomers accustomed to comets in our solar system, this sight was comforting. Here was something they recognized, not a riddle with no category, but a comet that behaved as comets should. A body of ice and dust, warmed by the sun, shedding material into space, glowing brightly for telescopes to see. And yet, the familiarity was deceptive, because though Borisov looked like the comets we knew, it was not one of ours. It did not share our sun's long history. Its ices were forged under a different star. Its dust came from worlds that circled another sun, perhaps planets we will never glimpse. To look at Borisov was to see the reflection of the familiar in the face of the alien. It was as though you were walking on a beach you know well, only to find a shell, unlike any and you've ever seen, shaped the same, patterned the same, but colored differently. Its spiral formed in waters you have never sailed. Scientists turned their instruments toward it eagerly. Spectrometers analyzed the light passing through its coma, teasing out the fingerprints of its chemistry. What they found was reassuringly similar to comets born under our sun: water vapor, carbon monoxide, dust grains. Borisov, for all its foreign origin, followed the same basic recipe. This in itself was a revelation. It told us that planetary systems across the galaxy may share common ingredients, that the icy bodies circling distant suns are not fundamentally different from those we know. The cosmos, in its immensity, repeats patterns. Comets are part of its shared language. But there were differences too. Borisov's tail released unusually high levels of carbon monoxide, more than typical for comets in our solar system. This suggested it formed in a region colder than most of our comets' nurseries, perhaps on the outer edge of its native system, in a frost belt, where even volatile gases could freeze. It was like tasting a dish that feels familiar, yet flavored with spices you don't quite recognize. The structure was the same, but the seasoning hinted at another kitchen, another home. For the public, Borisov's comet-like nature was a comfort. After the bafflement of ʻOumuamua, here was something that fit a picture book image: a glowing core, a streaming tail. For astronomers, it was both comfort and opportunity. Comfort, because the physics was familiar. Opportunity, because by studying it, they could compare it directly to the comets they had catalogued for centuries. Imagine looking through a telescope on a cold evening, watching its tail stretch faintly across the black sky. It is easy to forget, in that moment, that what you are seeing is not just ice and dust, but history. Borisov's nucleus carried within it the frozen record of a distant system, preserved for billions of years, now dissolving gently under the warmth of our Sunday. Some scientists said it was like holding a vial of seawater from an ocean on another world. In its chemistry was the story of another star's nursery, another protoplanetary disk. Studying Borisov was like opening a time capsule from a place we could never otherwise reach. And yet, the paradox remained. For all its foreign origin, Borisov looked so familiar that one could almost forget it was an alien visitor. It reminded us that the universe may not be entirely chaotic, but patterned, that the same laws of physics, the same chemistry, may produce similar results everywhere. Stars form, disks spin, ice condenses, comets emerge. From one system to another, the dance repeats, and the results rhyme. In this sense, Borisov was not only a comet, it was a bridge between the known and the unknown, between our small solar system and the wider galaxy. It said, "You are not unique. You are part of a pattern much greater than yourself." For those listening now, ready to drift into rest, let this image cradle your thoughts. A comet, glowing softly against the night sky, its veil of gas luminous, its tail stretching into forever. Familiar, yet foreign, stranger, yet kin. In Borisov, we saw ourselves reflected in the wider cosmos, tiny fragments of ice and dust warmed by the fire of a star shedding light as we go. And yet, beyond its comforting glow, Borisov carried a deeper significance. It was not only beautiful, not only familiar, it was proof. Proof that our galaxy is full of such wanderers, that our first sighting with ʻOumuamua was not a rare fluke. In the next part of our journey, we will explore why Borisov mattered so much, why its presence revealed the true abundance of interstellar travelers drifting between the stars. When Oumuamua slipped past us in 2017, it left the astronomical community in awe. For the first time in all of human history, we had seen something that came not from our sun but from another star. It was an extraordinary moment, a proof that the dark between suns was not empty but alive with wanderers. And yet, some wondered if we had simply been lucky. Was Oumuamua a once-in-a-lifetime event, a cosmic accident we happened to notice by chance? Or was it the beginning of something larger, evidence of a hidden population of interstellar travelers crossing our skies all the time? The answer came just 2 years later, in 2019, when Gennady Borisov appeared. Its very existence was an answer to doubt. If Oumuamua was the first scout, Borisov was the confirmation. The galaxy is not barren. Visitors from other stars are not rare. They are many. For scientists, this was transformative. A single data point could always be an outlier, an oddity, but 2 points form a line, and from a line, you can begin to see direction. 2 interstellar objects in such short succession suggested that they were not rare curiosities, but common participants in the great traffic of the galaxy. Astronomers began to run the numbers. If 2 such bodies were spotted within just a few years, how many must be passing unnoticed? After all, telescopes scan only a fraction of the sky at any given time, and these objects are small, faint, and fast. For every one we detect, countless others likely pass by unseen, gliding silently through the night. The calculations painted an astonishing picture. The Milky Way may be filled with trillions of interstellar comets and asteroids, drifting between stars, like pollen between flowers. Every planetary system, when young, is messy. Giant planets fling smaller bodies outward, scattering icy fragments into the void. Over billions of years, those fragments accumulate, filling interstellar space with debris. It is a quiet but ceaseless exchange, a cosmic circulation of stone and ice. Seen in this light, Borisov was not just a comet. It was proof of abundance, a reminder that our solar system is not sealed, but porous, part of a galactic flow. The same way rivers carry driftwood downstream, stars carry fragments outward, and sometimes those fragments wash into our shores. This abundance has profound meaning. For centuries, humanity has looked at the stars and wondered, are we alone? To answer, we have searched for signals, for radio waves, for signs of life on distant planets. But Borisov showed us something quieter, not life itself, but evidence that other worlds exist in tangible form. When a comet from another star passes us, we are not imagining its world of origin, we are literally touching it, in the particles of dust it sheds, in the gases it releases, in the chemistry written into its frozen heart. In Borisov's coma and tail, scientists found material that had formed around another star, preserved for billions of years, now drifting through our sky. It was as if a bottle from a distant ocean had washed onto our shore, carrying within it a sample of waters we will never sail. For astronomers, this was exhilarating. The cosmos had delivered not a message in language, but a message in matter, proof that other systems are not only real but accessible, at least in fragments, proof that the galaxy is one great ecosystem of exchange. And for dreamers, Borisov carried a subtler meaning. It told us that encounters are not rare miracles, they are part of the natural order. Just as migratory birds cross continents, just as seeds ride the wind across oceans, so too do comets cross between stars. We may feel small, isolated, marooned on a fragile planet circling a single sun, but in truth, we live on a thoroughfare, a crossroads where wanderers pass. Imagine that, trillions of travelers, each on journeys that began long before Earth's first forests, long before the first humans looked upward, each carrying the frozen memory of another star's nursery, each bound not for us, but through us, and every so often, we are lucky enough to see one, to greet it briefly before it slips away again. Borisov mattered because it ended doubt. It showed that Oumuamua was not a fluke, not a cosmic accident, but the first glimpse of a vast and ongoing story, and in that realization, the universe grew richer. There is comfort in this too. Loneliness fades when you realize you are part of a crowd. Even if the crowd is silent, even if its members never stop to speak, the knowledge of their presence is enough. Borisov was a reminder that we are not standing alone in an empty hall. We are standing at the edge of a great procession, and from time to time, we catch sight of one of its passers-by. Let yourself rest in that thought. Picture the night sky above you, a canvas of black and silver. Somewhere within it, unseen, countless fragments drift. Some are small, some large, some bright, some dim. Most will never come close enough for us to see, but some will, just as Borisov did, glowing softly in the warmth of our Sunday. The galaxy is not empty. It is alive with motion, with exchange, with abundance. And Borisov's presence gave us something else: hope. If comets can travel between stars, carrying with them the chemistry of their birthplaces, then so might the seeds of life. It raises the possibility that the galaxy is not only filled with stone and ice, but with potential, with the ingredients of life scattered like pollen across the interstellar wind. Perhaps Earth itself once received such gifts, in comets that came not only from our sun, but from distant stars. Perhaps we are, in part, children of this galactic exchange. Whether or not that is true, Borisov left us with the knowledge that the galaxy is generous, not stingy, that visitors will come again, and again, and again. That ʻOumuamua was not the end of a story, but the beginning of one. So as you drift deeper into rest, think of Borisov not as a solitary comet, but as part of a multitude, proof of the many, proof that the cosmos is a busy place, even if its traffic is slow and silent. Proof that the night sky above you is not an empty stage, but a living, breathing theatre, where countless actors drift unseen, waiting for their moment to pass across our gaze. And yet, while its mere presence was proof enough, Borisov also offered beauty. Unlike ʻOumuamua, it was generous with its light. It grew a luminous veil and a sweeping tail, visible to telescopes and cameras around the world. In the next part of our journey, we'll follow that glow, the shimmering coma and tail that stretched across the stars, and the science hidden within their light. Every comet tells its story not through words but through light. Unlike the silent rocks of space, comets glow. They carry within them ices that have been frozen for billions of years, waiting for the moment when sunlight will awaken them. As they draw near to a star, those ices begin to sublimate, changing from solid to vapor, and in that transformation, a veil of beauty is born. We call it the coma. With two eye, Borisov, the coma appeared quickly. By the time astronomers recognized it as interstellar, it was already wrapped in a luminous halo. Against the darkness of space, it looked like a tiny lantern glowing in the void. Its light, not its own, but borrowed from the Sunday. Dust and gas streamed away, scattering sunlight, painting Borisov with a shimmer visible across millions of kilometers. The coma is more than decoration. It is a laboratory, a chance to read the chemistry of a comet. Each molecule absorbs and releases light in a unique way, like a fingerprint. By splitting the coma's light into its spectrum, scientists could identify what Borisov carried within its icy heart. The results were both familiar and strange. Familiar because Borisov's coma contained water vapor, carbon monoxide, and dust, ingredients common to the comets of our solar system. Strange because the ratios were different. Borisov carried far more carbon monoxide than most local comets, suggesting that it had formed in an environment colder than the outer reaches of our sun's domain. Perhaps, in its original star system, it was born even further from its parent star than Pluto lies from ours. Think of that, a comet carrying within it the climate of another system. In its chemistry, the story of a distant nursery was preserved. Just as the taste of fruit reflects the soil where it grew, Borisov's coma reflected the conditions of a world we will never see. The coma also gave birth to a tail, or rather, two. Comets produce both a dust tail and a gas tail. The dust tail curves gently, following the path of the comet's orbit, like a ribbon streaming behind a dancer. The gas tail, on the other hand, points straight away from the sun, driven by the solar wind, a stream of charged particles flowing outward. Borisov's tail stretched across space, faint but measurable, painting lines against the starry canvas. Through them, astronomers could measure the rate at which material was leaving the comet, the size of the grains, the force of the sun's influence. Every detail was a clue. For those who gazed at images of Borisov, the beauty was undeniable. A glowing head, a faintly curved tail, drifting against the infinite black. To know that this light came not from one of our own comets, but from a visitor born under another sun, gave it an almost mythic quality. It was as though a lantern from another village had floated down the river of stars, briefly illuminating our night. And yet, the science deepened the poetry. In the gases streaming from Borisov, astronomers found information about the building blocks of distant worlds. In its dust, they found grains larger than expected, suggesting that its nucleus was rich and sturdy, capable of holding together across its immense journey. In its composition, they saw hints that planetary systems everywhere may follow similar recipes. To watch Borisov's coma was to hold a mirror up to our own origins. Our solar system, too, was once a disk of gas and dust, forming comets at its edges. Those comets may have carried water to Earth, seeding the oceans where life later bloomed. If Borisov's system had planets, perhaps its comets served the same role. And here, in its glow, was proof that the same processes unfold in faraway suns. The coma also carried a reminder of fragility. Comets are not eternal. They are ephemeral sculptures, slowly dissolving each time they approach a star. Borisov, too, shed its mass as it neared our sun, losing ice and dust into space. In time it will dwindle. What passes us now is only a fragment of what it once was. But in that fragility lies beauty, the beauty of impermanence. Like a snowflake melting on a child's hand, Borisov's glow was precious because it would not last. For those who let their imagination drift, the coma was more than gas and dust. It was a veil, a cloak, a sign of passage. It made Borisov visible, yes, but it also made it haunting. To see it glow was to know that it was alive, in a sense, not with life as we define it, but with motion, with transformation, with the restless energy of a traveler warmed by a borrowed sun. And as its coma shimmered, telescopes around the world turned their gaze toward it. Instruments from Earth, and even from space, captured its spectrum, measured its brightness, traced its tail. For months, Borisov was the subject of attention, the centerpiece of astronomical curiosity, and yet, through it all, it remained quiet, indifferent, moving on its own path. Perhaps that is why its glow feels so comforting, because in its light, we see a reflection of our own desire to be noticed. Borisov did not come to us intentionally, but in its coma and tail, it made itself visible, unavoidable, unforgettable. It reminded us that even the smallest body, drifting alone through space, can shine when warmed by a star. As you rest now, let that image cradle you, a glowing comet against a field of stars, its veil of gas shining, its tail stretching like a silver thread into the darkness. Imagine it not as an object of cold science, but as a companion, familiar in form, foreign in origin, luminous in its passage. But Borisov's light carried more than beauty. It carried clues. In its vapor and dust were the fingerprints of its birth, the chemistry of another system. In the next part of our journey, we will lean closer, to read those clues, to ask, what exactly was Borisov made of, and what does its recipe tell us about the worlds beyond our sun? Every traveler carries traces of home. A sailor smells faintly of salt, a desert wanderer carries dust in the folds of their clothes, and even the most distant pilgrim leaves footprints shaped by the soil of their birthplace. So too with comets. They are fragments of worlds, bottled samples of the conditions in which they formed. When 2I, Borisov, came to us, it brought with it not words, not deliberate messages, but the chemistry of another star's nursery, carried intact across millions of years and light years of space. For astronomers, this was a rare chance. With ʻOumuamua, the first interstellar visitor, there had been little to study, no coma, no tail, only fleeting light curves. But Borisov was generous. It bloomed with vapor and dust as it neared the sun, spreading its secrets outward into the dark. All we had to do was look carefully. And so they did. Telescopes across the world, from small instruments to the grand giants, pointed toward its faint glow. Spectrometers split the light from Borisov's coma into colors, revealing the fingerprints of atoms and molecules within. Each gas left its mark, each dust grain its clue. The first and most familiar discovery was water vapor. Just as with our local comets, Borisov's ices turned to gas when warmed, releasing streams of water molecules into space. This was no surprise, but it was still profound. Water is one of the most universal markers of life's potential, and here it was, evaporating from a comet born under another sun. The oceans of Earth, in part, may have been seeded by comets long ago. Perhaps Borisov's home system too had oceans once, or still has them now. But Borisov carried more than water. Its coma was rich in carbon monoxide, far more than most comets in our solar system. Carbon monoxide is a volatile gas, freezing only in the coldest regions of space. Its abundance suggested that Borisov had formed far from its parent star, in a realm of deep frost where even the most delicate ices could condense. If our comets are children of the outer solar system, Borisov was a child of the farthest outskirts, beyond even the cold we know. This was remarkable. It meant that while comets across systems may share ingredients, the proportions vary depending on where they are born. Like bread baked with different grains, or wine pressed from different soils, Borisov's chemistry reflected its homeland. It was the taste of another system, preserved in ice. Other molecules appeared too. Astronomers detected cyanides, simple compounds of carbon and nitrogen, common in comets but always intriguing, since they are precursors to more complex organic chemistry. Dust grains from Borisov glowed in the light, some larger than expected, suggesting that its nucleus was sturdy and cohesive. This was not a fragile snowball, but a well-packed traveler, resilient enough to survive the violence of ejection from its star and the long drift through interstellar space. What did all this mean? In part, it confirmed that the processes shaping comets are universal. Stars form from clouds of gas and dust. Around them, disks spin, particles collide, ice condenses. In every system, at every edge, comets form as frozen archives of those early days. Borisov was proof that what happens here, under our sun, happens everywhere. But in part, it also showed diversity. Borisov's high carbon monoxide content, its different proportions of gases, spoke of variations between systems. Not all stars bake the same recipes. Some worlds may be born wetter, others drier. Some rich in carbon, others poor. The galaxy is one vast kitchen, producing billions of worlds, each flavored slightly differently. For those who dream about life in the cosmos, this chemistry was tantalizing. If comets carry water and organics in our system, seeding young planets with the ingredients of biology, then surely the same happens elsewhere. Borisov was not life, but it carried the potential for life's building blocks. It was a reminder that the seeds of possibility are not rare or confined. They are scattered widely, carried from star to star, like pollen drifting across a meadow. Let us pause here and picture Borisov in your mind's eye. A small nucleus, perhaps only a kilometer or two across, dark and solid. Around it, the warmth of the sun lifts ices into gas, forming a glowing halo. In that halo swirl molecules of water, carbon monoxide, cyanides, dust grains, the frozen memory of another world. As you imagine it, let the thought soothe you. The galaxy is not barren. It is full of ingredients, full of exchange, full of echoes of other suns. There was something humbling, too, in the knowledge that Borisov was sacrificing itself for us. Every gram of ice that evaporated was a piece of its body, lost forever. Each molecule measured was part of its being, dissolved into light so that we could learn. Borisov, in a sense, gave itself away. By the time it left, it was smaller, diminished, a little more fragile, but in that sacrifice, it gave us a glimpse of its origin. Perhaps that is why comets have always stirred human imagination. They are at once ephemeral and eternal. Ephemeral because they glow only briefly, shedding their substance until they vanish. Eternal because they carry with them the chemistry of creation, unchanged for billions of years, delivered across space and time. Borisov was both, a fleeting glow and an ancient archive, a visitor from a world we will never see, and yet, in its chemistry, a link to us. So as you rest tonight, let this be your lullaby. Every comet is a story written in ice. Borisov's story was not only its journey, but its substance. It told us that the galaxy is generous with its ingredients, that the building blocks of water, carbon, and dust are not unique to our sun, but woven into the very fabric of starlight. That what makes life possible here may also make it possible elsewhere. But Borisov's chemistry was only part of its story. Its path through the solar system was just as telling, an arc that never closed, a trajectory that confirmed its nature as a wanderer. In the next part of our journey, we'll trace that path together, the hyperbolic curve of a traveler that comes once and then is gone forever. Every object in our solar system moves to a rhythm written by the Sunday. Planets circle endlessly, each in its orbit. Asteroids dance in slow ellipses. Even comets, those icy drifters from the edges of the solar system, follow paths that always bend back, like boomerangs tossed into the dark. Their journeys may take decades or millennia, but eventually they return. They belong to the sun, caught in its gravity, bound to its pull. But 2I, Borisov, was different. Its path did not bend inward and close upon itself. It did not loop or promise return. It traced a curve that opened outward forever, a hyperbola. The mathematics of orbits is like a language. Circles and ellipses tell of belonging, of being held. A parabola tells of escape, just barely free. A hyperbola tells of something more decisive, a traveler already unbound, already free before it arrived, passing by once and vanishing forever. Borisov's orbit was unmistakably hyperbolic. This meant one simple truth. It was not ours. It had never belonged to the sun and never would. It was not born in the Oort cloud, not shaped by Jupiter's tug, not part of the slow ballet of local comets. It came from elsewhere, from another star, another system, drifting across the galaxy until chance brought it through our sky. The numbers confirmed the poetry. Borisov's velocity, even before it encountered the sun, was too great for gravity ever to hold it. It approached our system at nearly 33 kilometers per second, faster than any bound comet could travel. After its closest pass to the sun in December 2019, it accelerated outward again, on its way back into the abyss, carrying its fading coma with it. To picture its path, imagine a stone skipping across water. The water is the sun's gravity, pulling gently, curving its trajectory slightly. But the stone is too fast, too free. It touches the surface once, bends for an instant, then sails onward, never to return. Borisov's hyperbola was that skip, one brief touch, and gone. There is a kind of bittersweet beauty in this. Comets like Halley's may vanish for a time, but we know they will return, like old friends on long journeys. Borisov offered no such promise. It came once, and we will never see it again. Its farewell was written in its orbit from the very beginning. And yet, that is what made its visit so precious. The fleetingness heightened the wonder. Knowing that Borisov was a once-in-humanity sighting, we cherished each observation, each spectrum, each faint photograph. Astronomers hurried, not because the comet would vanish forever behind the sun, but because it was slipping away into eternity. Every day it grew dimmer, fainter, farther. Each measurement was a gift, each moment a farewell. In this way, Borisov became a lesson in impermanence. All things drift, all things pass, all things follow their own curves. Some return, some do not. To watch Borisov was to be reminded that not all encounters are meant to last. Some are brief touches, glances across the cosmic station, proof that we are part of a larger traffic even if the travelers never stay. Astronomers traced its hyperbolic path backward, hoping to find its origin. Where in the galaxy had it come from? But the trail dissolved into uncertainty. Interstellar space is vast, and the comet had wandered for millions, perhaps billions, of years. Its trajectory, though precise now, lost clarity when projected backward across such immense times. No star could be confirmed as its birthplace. Its home remained hidden. This mystery deepened the poetry of its orbit. It was not only a visitor, it was an orphan, a body cast out long ago, its original system forgotten, its parent star untraceable. Now it would wander again, toward destinations unknown, a citizen of the galaxy rather than any single sun. Imagine, for a moment, being carried on its back. You approach a new system, slip past its bright star, warm enough to awaken your ices, glowing for a brief season. Then, just as quickly, you leave again, the warmth fading behind you, the darkness wrapping around you once more. For millions of years, this is your fate. Eternal motion, eternal exile, never returning, never belonging. And yet, perhaps there is freedom in that exile. Bound comets are trapped in loops, repeating endlessly, their futures predictable. Borisov, by contrast, is free. It may never belong, but it also never returns to the same place. Its journey is forward, always forward, into the unexplored. For us, watching from Earth, this freedom carried meaning. It told us that our solar system is not an island fortress. The walls of gravity are porous. Wanderers can and do pass through, bringing with them stories of other suns. Borisov's hyperbola was not only a trajectory, it was a bridge, proof of the galaxy's interconnectedness. As you drift deeper into rest, let this image soothe you. A comet arcing once past a star, glowing briefly, then vanishing into the distance. No return, no repetition, just a single moment of beauty on a journey without end. There is comfort in cycles, yes, but there is also wonder in the unrepeatable, the singular, the fleeting. Borisov was such a wonder. And so, we let it go. We watched until it was too faint to see, until even the largest telescopes could no longer trace its light. We let it slip back into the stars, into the silence, carrying with it its chemistry, its dust, its story. We will not see it again, but we will remember. Its hyperbolic path is etched into our science and into our imagination. Yet while Borisov's orbit told us of its freedom, its behavior also invited comparison. For in so many ways it looked like the comets we already knew, Halley, Hale-Bopp, the countless icy wanderers of our own solar system. In the next part of our journey, we'll place Borisov among them, side by side, and ask, what does it mean when a stranger looks so familiar? When we meet a stranger, we often compare them to the people we already know. A familiar smile, a gesture that recalls a friend, a tone of voice that reminds us of family. It is how we make sense of the unfamiliar, by placing it alongside the familiar. Astronomers, too, are no different. When 2I, Borisov, appeared, glowing in our skies, the first instinct was to compare it with the comets we had studied for centuries. And in so many ways, Borisov looked like one of our own. Take, for example, Halley's Comet, perhaps the most famous of all. It returns every 76 years, bright enough to be seen by naked eyes, carrying with it a luminous tail that has inspired awe for millennia. Like Borisov, it is a ball of ice and dust. Like Borisov, it glows when sunlight awakens its ices. And like Borisov, it sheds streams of material that trail behind it, a glittering ribbon in the dark. Or consider Comet Hale-Bopp, which blazed across our skies in 1997, visible for a record-breaking 18 months. Its coma was immense, its tails spectacular. People around the world looked upward and felt small, humbled, inspired. Again, the parallels to Borisov were clear, an icy nucleus transformed by sunlight into a glowing beacon, a traveler crossing our skies before slipping away into the depths. To see Borisov was, in many ways, to see a cousin of these comets, familiar in behavior and similar in appearance. Its coma shone, its tails streamed, its chemistry was recognizable. It followed the same physics, obeyed the same rules of light and gravity. In photographs, if you did not know its story, you might think it was just another comet from our own Oort cloud, a neighbor on a long elliptical path. And yet, the comparison also revealed the subtle differences that made Borisov unique. For one, its orbit was hyperbolic, not elliptical. While Halley and Hale-Bopp will return eventually, Borisov will not. Its path told us immediately, this is not one of ours. Its home lies far beyond. Its composition, too, set it apart. The high levels of carbon monoxide in its coma suggested a colder birthplace than the one that nurtured most of our comets. It carried the fingerprint of a star system whose chemistry was similar, but not identical to our own. Even its appearance was subtly different. Astronomers noted that its coma was less compact, more diffuse than many solar system comets. Its dust grains were larger, its nucleus smaller than Hale-Bopp's giant heart. It was, in a way, humbler, less spectacular to the naked eye, but more extraordinary in origin. These differences mattered because they told us something profound. The universe is both consistent and diverse. Consistent in that the laws of physics and chemistry repeat across space. Water freezes, sublimates, and glows under sunlight no matter which star it calls home. Dust reflects, gas streams, tails form, but diverse in that the details vary, proportions, compositions, intensities, all shaped by the unique environment of each star's nursery. Borisov, then, was a bridge. It showed us that our comets are not alone in their kind, that other stars also produce icy wanderers, bound by the same rules but marked by their own accents. It was like hearing a familiar song sung in a different language, recognizable yet new. There is comfort in this comparison. To know that the galaxy is filled with comets like ours is to know that the processes that made us are not rare. If comets deliver water to planets here, they likely do so elsewhere. If they carry organics here, they likely do so elsewhere. Life's ingredients, it seems, are scattered widely, delivered again and again on icy messengers from the stars. Imagine, for a moment, standing under the night sky as Borisov passes. You cannot tell, with your eyes alone, that it is foreign. It looks like Halley, like Hale-Bopp, like any comet you might see once in a lifetime. And yet, in your mind, you know the truth. It is not from here. It is a visitor from another sun. That paradox, familiar and foreign at once, is part of its magic. It is as if a traveller walked into your village, wearing clothes much like yours, speaking gestures you recognize, yet carrying an accent you cannot place. You feel kinship, but also distance. You see yourself reflected, but also something beyond yourself. Borisov was such a traveller. For scientists, comparing Borisov to local comets was more than poetry, it was science at its best. Every similarity confirmed that planetary systems share common processes. Every difference hinted at new environments, new possibilities. Borisov expanded the sample size of comets from one star system to two. It was a tiny step, but monumental nonetheless. And for dreamers, the comparison carried another lesson. We are not unique, but we are not alone. The universe recycles its patterns, shaping comets in system after system, scattering them into the dark. We are part of a cosmic family, one branch among countless others. As you drift deeper into rest, let that thought comfort you. The night sky above is not a random scatter of unrelated lights, but a network of kinship. Stars form families of planets. Planets shed comets. Comets wander across the galaxy, and sometimes they come to visit us, carrying reminders that the universe repeats itself in beautiful, familiar ways. So Borisov became not just a comet, but a mirror. By comparing it to Halley and Hale-Bopp, we saw both our likeness and our differences. We saw that we belong to a wider pattern, that what we know here is echoed elsewhere. And in that echo, we found reassurance. We are not isolated oddities, but part of a cosmic chorus, each star singing variations on the same song. Yet Borisov's story was not only about chemistry, or tales, or comparisons. It was also about the man who discovered it, an amateur astronomer with a homemade telescope who, through patience and love, touched the stars. In the next part of our journey, we will turn from the comet itself to its discoverer and reflect on what his quiet triumph means for us all. When we think of great discoveries in astronomy, our minds often leap to vast observatories, towering domes on mountain peaks, instruments worth millions, collaborations that span continents. It is easy to imagine that only such giants can touch the infinite, but sometimes history is written not by institutions, but by individuals. Sometimes all it takes is a pair of steady eyes, a quiet determination, and the patience to look up when others are asleep. Such was the story of Gennady Borisov, the man whose name became bound forever to the second interstellar visitor we have ever known. Borisov was not a professional astronomer. He did not work at a university, nor did he belong to an international consortium. He was, in the truest sense, an amateur, a lover of the stars. By day, he repaired and built telescopes. By night, he used them. In a small workshop, with his own hands, he crafted the instruments that would later carry his name into history. Imagine that devotion. While others bought their telescopes, Borisov built his. He ground mirrors, aligned optics, designed mounts, and tuned lenses until they were sharp enough to pierce the heavens. His observatory in Crimea was modest, nothing like the massive domes of Hawaii or Chile. And yet, on a late August morning in 2019, it was there that he noticed a faint smudge in the sky, a comet unlike any he had seen before. At first, it seemed ordinary, a hazy spot, diffuse, glowing faintly against the black. But over days, the truth emerged. Its path was hyperbolic, its speed too great, its orbit unbound. This was no local comet from the Oort cloud. This was a traveler from another star. When the International Astronomical Union confirmed the discovery, they named it 2I, Borisov, the second interstellar object ever found, and the first interstellar comet. The Borisov was more than a designation. It was a recognition that a man, working largely alone, with a telescope of his own making, had reached across the galaxy and touched a wanderer from another sun. For Gennady, this was not an act of luck but of perseverance. He had spent decades scanning the skies, often in the quiet hours when most of the world slept. Night after night he had trained his instruments upward, logging faint comets, searching for new ones, letting patience be his compass. His discovery was the fruit of love, not chance. In this, Borisov's story holds a gentle lesson for us all. Great achievements are not always born of great resources, they are born of attention, of showing up, again and again, with eyes open and heart steady. They are born of devotion to something larger than ourselves. Astronomers around the world celebrated him, not only for the comet itself, but for what his discovery represented, that science is not closed, not locked away in ivory towers. The sky belongs to everyone, and sometimes the most extraordinary contributions come from those who look up simply because they love to. In the glow of his discovery, many remembered the long tradition of amateur astronomers who shaped the history of the stars. It was amateurs who discovered many comets, who tracked eclipses, who mapped craters of the moon. Gennady joined that lineage, a reminder that the cosmos is democratic. It offers its wonders to anyone willing to look carefully enough. And what a legacy he created. Long after Borisov the man is gone, Borisov the comet will remain in the annals of science. Textbooks will recall it as the first interstellar comet ever seen. Its name will be spoken not only in classrooms but in whispers of wonder, each time humanity remembers the moment a stranger from another star crossed our sky. But beyond the science, there is poetry in his achievement. To think that a human being, standing on a small peninsula by the Black Sea, could with his own tools detect something born under another star system, it is a reminder of our place in the cosmos. We are small, yes, but not powerless. We are brief, yes, but capable of touching eternity with our gaze. Picture him now, that night. The air cool, the telescope pointed upward, the stars wheeling silently. A faint blur catches his eye. He notes it, returns the next night, sees it shift against the background. A comet, he thinks. But soon the numbers whisper more. Faster, farther, stranger. Not from here. Not bound. A traveller. A messenger. In that quiet moment, Borisov's devotion was rewarded. His legacy was sealed. And perhaps that is why his story resonates so deeply, because it reminds us that discovery is not only for those with wealth or status or access to giant machines. Discovery is for anyone who looks with care. The universe does not play favorites. Its secrets are scattered across the sky, waiting to be noticed. So, as you rest tonight, let this story be your lullaby. Think of Borisov, standing alone beneath the stars, guided by love, rewarded with wonder. Think of the comet that carries his name, glowing as it slipped past our sun, proof that the galaxy is alive with travelers. And let it remind you that you too can find meaning in quiet attention, in patience, in love. Gennady's legacy is not only the comet, it is the truth that each of us, in our own way, can touch the infinite. Yet Borisov's story was not only about discovery, it was also about meaning, about what his chemistry, his tale, his very presence told us about the galaxy. In the next part of our journey, we will follow those implications. What does Borisov reveal about other worlds? And what can a comet's drifting dust teach us about the stars beyond our own? Every comet is a story written in ice. Our own comets, born in the deep reaches of the solar system, carry within them the frozen memory of its beginning, the chemistry of the primordial disk, the whispers of collisions, the fingerprints of temperature and distance from the sunday. To study a comet is to open a time capsule of creation. When Gennady Borisov arrived, it brought something even rarer. It was not only a memory of our beginnings, but of another star's, B.A. It was a letter from elsewhere, written in the language of chemistry, a fragment of a system we may never see, delivered to us by the patient drift of interstellar space. Astronomers pointed their instruments at it and found both the familiar and the unfamiliar. Its coma contained water vapor, just as our comets do, reminding us of a shared recipe across the cosmos. But its chemistry was flavored differently, with unusually high levels of carbon monoxide, suggesting it had formed in a region far colder than the nursery of most of our own comets. It was like tasting a familiar fruit and noticing a hint of spice from a soil you do not know. The dust it shed also carried meaning. Larger grains than expected shimmered in the sunlight, betraying a nucleus strong enough to endure ejection from its native system and the long crossing of interstellar space. Each grain was a tiny seed, the raw material of planets, the kind of substance from which entire worlds might grow. To study Borisov was to hold a fragment of another star's potential, a handful of the same ingredients that may once have shaped planets circling a foreign sun. What Borisov revealed was that the galaxy is not chaotic but patterned. The physics and chemistry that gave rise to our solar system also unfold elsewhere. Stars form from clouds of dust, disks spin around them, comets condense at their edges. The details shift, but the script is the same. There is comfort in this repetition. It means that what happened here is not rare. The building blocks of life are scattered widely, and the seeds of possibility drift across the galaxy like pollen on a cosmic breeze. For some scientists, Borisov even reignited the question of panspermia, the idea that comets could carry not just chemistry, but perhaps even the simplest forms of life across the stars. We cannot know if Borisov carried such precious cargo, but its very survival over light years made the question feel less like fantasy and more like quiet possibility. If ices and organics can endure such journeys, why not life's most delicate beginnings? To think of Borisov is to picture a cosmic river flowing between the stars, carrying trillions of fragments from one system to another. Most drift unseen, but some, by chance, cross our path. Each one is an emissary, unintentional but profound, reminding us that our solar system is not a closed island, but a harbor on the galactic current. We are not alone in stillness. We are part of a traffic that spans the Milky Way. For those of us who watch from Earth, this realization brings both wonder and comfort. It tells us that the chemistry that made us is not ours alone, that the water in our oceans, the carbon in our bodies, the dust in our bones, all of it echoes across countless other suns. To look at Borisov was to look at a mirror, faint and distant, showing us that we belong to a pattern much larger than ourselves. As you rest tonight, let this truth settle in you like a lullaby. The galaxy is not barren but alive with drift and exchange. The same chemistry that shaped our world is shaping others, and the same ices that seeded our beginnings are scattered everywhere. Borisov's glow was not only a comet's light, it was a reminder of kinship, a quiet assurance that even in the vastness, we are not isolated but connected by the patient drift of matter through the stars. And yet, while Borisov showed us the diversity of worlds, it also gave us comfort in its familiarity. For though it was foreign, it looked so much like the comets we already knew, glowing softly, trailing a silver tail. In the next part of our journey, we will rest with that reflection, the comfort of seeing a stranger who feels like home. Every encounter with an interstellar visitor carries a kind of fragility. From the moment we first glimpse it, we know that it is fleeting, that the time we share is measured not in centuries or even decades, but in months, perhaps weeks. The same was true of Gennady Borisov. It arrived quietly, it glowed for a short while, and then it began to fade. Its path, written in the language of hyperbolas, had already told us the truth. It would not return. As the weeks turned into months, telescopes across the world continued to watch it. In December 2019, it made its closest pass to the sun, glowing most brightly, its tail stretched across millions of kilometers. But after that, the light began to weaken. Each day it drifted farther, growing fainter against the backdrop of stars. By the spring of 2020, it had slipped beyond the reach of most instruments. By the summer, it was nearly gone, a whisper in the data, a memory in the night. What lingers in moments like these is not the sight itself, but the knowing that we witnessed something ancient, something that had traveled across the void for longer than our species has existed, knowing that we will never see it again. Borisov's farewell was quiet, no explosion, no drama, just a fading glow, a slow retreat into distance. It was the kind of goodbye that feels almost like a dream. You wake and wonder if it happened at all. And yet, like a dream, it left an imprint. For months, Borisov had carried the attention of astronomers, poets, dreamers. It had become a symbol, a reminder that the universe is not static, that it delivers surprises, that even from the most distant suns, fragments can drift into our skies. Its passing was a lesson in impermanence. Beauty does not last, but it lingers in memory. To imagine Borisov now is to picture a small, dark nucleus, tumbling slowly, its coma faint, its tail gone. The sun is far behind it, just another star in its rear view. Ahead lies only darkness, but not emptiness. The galaxy stretches before it, a sea of possibilities. Borisov will continue to drift, perhaps forever, an eternal wanderer without destination. It will never be captured, never return, never settle. It belongs to no one star, and so it belongs to all. There is sadness in this, yes, but also peace, because Borisov's gift was not in its permanence, but in its passing. Its glow reminded us of kinship. Its chemistry told us of other worlds. Its presence proved that we are part of a river of travelers flowing through the Milky Way. And though it has gone, those truths remain. In many ways, Borisov's farewell mirrors the comets of our own solar system. Halley vanishes for decades, Hale-Bopp for millennia. They too fade, leaving us only with the knowledge that they will return one day. Borisov offers no such promise, but perhaps that makes it even more precious. We knew, as we watched, that this was our only chance, and we took it. We measured, we learned, we marveled, we said goodbye. For you, dear dreamer, resting here tonight, Borisov's story can be a mirror for your own thoughts. Life is filled with fleeting encounters, moments that come once and never return. A passing smile, a day of joy, a night under the stars. They vanish, but they matter. Borisov reminds us that even a brief presence can change us. Even a short glow can illuminate the darkness. So let its farewell comfort you. Imagine it now, far beyond our sun, a tiny fragment drifting alone. Its glow is gone, but its journey continues, and in some quiet way, so does ours. We too are wanderers born of starlight, moving through time, carrying with us the chemistry of creation. As Borisov slips away forever, let us not feel loss, but gratitude. Gratitude that we saw it at all. Gratitude that the universe shared with us this visitor. Gratitude that in its passing, it reminded us of connection. And as your eyes grow heavy, imagine yourself drifting with it. The stars all around, the sun behind you, the galaxy before you. No urgency, no destination, just motion. A quiet journey into forever. There is peace in that image, peace in the letting go. And so, dear dreamer, our story with 2i, Borisov, comes to its end. From its discovery by an amateur astronomer with a handmade telescope, to the glow of its coma, to the secrets it whispered of other worlds, to the quiet comfort of its familiarity, and now to its farewell. It came once, and it will not return, but in that one passage, it gave us wonder enough to last. May this story soothe your thoughts tonight. May it remind you that even in the vastness of space, we are part of patterns, part of kinship, part of a universe that repeats beauty again and again. So rest now. Let the comet drift away, and let your own mind drift into sleep. The night will hold you. The stars will keep watch. And tomorrow, when you wake, the memory of Borisov's glow will still be with you, gentle, distant, eternal. Good night, traveler. Sleep peacefully, and may your dreams be as endless and as serene as the galaxy itself.